We're going to now take the right triangle trig and give you a couple examples to solve for sine, cosine, tangent, cosecant, secant, and cotangent. So here's our first example. We give you a right triangle, and we want you to find these 6 trig functions. So here is our 90-degree triangle, and then here's our angle theta, which is unknown. And then we give you a couple sides. We give you the side of 4, which is what we call the opposite, the side of 3, which is the adjacent, and then we have some unknown side length of the hypotenuse. So before we begin finding the 6 trig functions, we need to find out what is the side length of hypotenuse. If you remember Pythagorean theorem, a squared plus b squared equals c squared. Remember, hypotenuse is always the c in the Pythagorean theorem. So let's go ahead and solve for c. So we take a squared plus b squared, and it's going to equal our c squared. Now we're going to go ahead and simplify that equation. So 4 times 4 is 16. 3 times 3 is 9. Equals c squared. Add those two numbers together, and you get 25 equals c squared. To undo that c squared, we have to square root both sides. And you don't have to worry about the negative in that radical because you can't have a negative length in a triangle. So c equals 5. So now we can come back over here, and the hypotenuse is a length of 5 units. Now, if you remember from a previous video, these 6 are our trig functions with the equation. So please make sure you're looking at your notes when we do this. All right, so we want to find the sine, cosine, tangent, secant, cosecant, and cotangent. So the first one is sine. Remember, the sine is so for short. So sine is opposite. So opposite is 4. And hypotenuse is 5. So we're going to just leave it as a fraction, so 4/5. The next one is cosine. Cosine, remember, it is co. So adjacent, which is 3. And the hypotenuse, which is 5. The last one to remember is tangent. So TOA is the way we remember it. Opposite over adjacent. Opposite is 4. And adjacent is 3. Now what we've done is we found the 3 big trig functions. To find the next 3, I'm going to just flip-flop the ones on the left. So to find the secant, I'm going to just flip-flop the cosine. So to find the secant, I'm going to flip-flop the cosine. So now I'm going to go 5 over 3. To find the cosecant, I'm going to flip-flop the sign. So it's going to be now 5 over 4. And please make sure you leave them as fractions. The last one, tangent, or cotangent, is the reciprocal of the tangent, the inverse of the tangent. So now it's going to be 3 over 4. Here is a right triangle, and now we give you the cotangent of theta is 5. So I'm going to go ahead and put that down here. The cotangent of theta is 5. And we want to find the third side of the triangle and then find the other 5 trig functions. So I have a right triangle here with our 90 degrees and our theta and that information of the cotangent of theta. If you remember, the cotangent of theta is the inverse of the tangent. So if tangent is TOA, opposite over adjacent, then cotangent has to be adjacent over opposite. So if we look over here, this is 5. Well, it's not written as a fraction, so I'm going to throw a 1 on the bottom. So 5 over 1 is 5. Now I know 2 out of the 3 sides. So I'm going to identify the 3 sides. This is opposite, adjacent, and hypotenuse. Now adjacent is 5 units. I'm going to put that here. Opposite is 1 unit, and we don't know the hypotenuse. So we're going to use right triangle, or not right triangle, we're going to use Pythagorean theorem and solve for that hypotenuse. A squared plus b squared equals c squared. We've already done that in the previous examples. So a squared plus b squared equals c squared. Plug in our numbers. 5 squared plus 1 squared equals c squared. Simplify it. 5 times 5 is 25. 1 times 1 is 1. And we get c squared equaling 26. Now we need to undo that c, so we're going to square root both sides. Now that is not a very nice number, so we're just going to leave it alone in exact form. So c equals the square root of 26. I'm going to go ahead and label that back up here as my hypotenuse. Now I know my 3 sides of my right triangle. Now I can evaluate the rest of the trig functions. So start with sine. Remember, sine represents opposite over hypotenuse. So opposite is 1. Hypotenuse is square root of 26. Now I'm going to leave it alone for right now. A little bit later we do have to clean it up. We're going to have to rationalize the denominator. Next one is cosine. Cosine, if you remember, is co, adjacent over hypotenuse. So adjacent is 5. Hypotenuse is square root of 26. The last one of the big 3 is the tangent. And tangent is right here, opposite over adjacent. Opposite is 1, and adjacent is 5. Now we're going to go ahead and find the other missing trig functions by reciprocating. So if I want to find the secant, I reciprocate or inverse the cosine. So now it's going to be the square root of 26 over 5. If I want to find the cosecant, I reciprocate or inverse the sine. So I'm going to flip-flop the 1 over 20 square root of 26 as the square root of 26 over 1. All right, now we found the 6 trig functions, but some of them we have to clean up. We have to make them a little bit more proper. So the first one, the cosine of theta. You need to rationalize that denominator. So I'm going to multiply the numerator and denominator by the square root of 26. So now I get 5 square roots of 26. Square root of 26 times square root of 26 is just 26. So there's my answer for the first one. This one is fine, so we'll leave it alone. Sine of theta needs to be rationalized, so I'm going to multiply the numerator and denominator by the square root of 26. I get square root of 26 over 26. This one over here, square root of 26 over 1, can just be reduced to the square root of 26. 1/5 is fine, and 5 is fine. And that's how you can find the 6 trig functions, given one of the trig functions.